Welcome, everybody, to our third MathWorks mini-series session. We're just going to wait for a couple minutes, and then we'll go ahead and get started. We are so glad you guys are here. Just hold on for a couple more minutes. Thank you. Welcome, everyone. My name is Alicia Gavin. I am the Director of Communications and Marketing here at RoboNation. We are very excited to be joined by one of our very special sponsors to us that has been a longtime member of the RoboNation community, MathWorks. And so this is our third MathWorks mini-series session. If this is the first time you're joining us, feel free to visit our YouTube channel. We've got 2 more from this year. Welcome, everyone, as well as some additional videos from previous years when we've done other MathWorks mini-series. I'm very excited, like I said, to have you guys joining us. So please feel free to ask any questions throughout this webinar. We've got Abhishek Shankar, and I'm going to pass it over to him to get started. Thank you.
Thank you, Alicia, and welcome again, everyone. This is the final session of our MathWorks mini-series, and I'm excited to present to you how to integrate Simling with the VRX simulator. So if you haven't as Alicia said, if you haven't seen the last two webinars, I would encourage you to go check it out in the RoboNation YouTube channel. We have some exciting stuff showing you how to develop complex algorithms in those videos. So coming to this one, let me give you a brief overview of what I'm going to be talking about today. We'll do a brief introduction of the VRX simulator and the task that the algorithm that we're going to do. Talk briefly about the simulator, and then do some image processing and touch upon the MathWorks award for the robotics competition, and finally conclude the presentation. So, like we said in the last two videos, we showed how to develop control systems and deep learning algorithms in MATLAB and Simulink. We also saw how you can deploy the code as ROS nodes to your simulator or your target hardware. And then we're going to talk about how to do the same with the VRX simulator, which is very popular for robotics. So it's an open source simulator which was developed by OSRF for the virtual robotics competition. And it has a WAM-V boot on in the default world, and then has a bunch of sensors and also a default thrust configuration. So here, if you see, you have two thrusters and then some sensors like cameras, lidars, GPS, and IMU. So this provides a great test bed for testing all your algorithms and competition strategies. You could develop really robust control algorithms, navigation algorithms, or kind of use it as a sanity check to make sure all your um, values that being provided to the controller are being correct, or it's in a reasonable threshold of threshold for acceptance. So let me move on to the image processing part. I'm going to be opening Simulink for this. Yeah. So in this webinar, the main focus is going to be on how to subscribe to topics from the VRX, and then how to do image processing in Simulink. So I took image processing as an example, but you could take any of the other content that I covered in the previous videos. So for example, you could replace this block with a control system block, or you could replace this with the deep learning network to do your process. So in this case, we're not going to do deep learning because not a lot of tasks explicitly require deep learning. That's one case, and the other one is deep learning is also very compute intensive. If the classical computer vision techniques have been applied properly, you could get away with a lot of good results by using far less compute. Um, excuse me. So let me walk you through the model a little bit. So we have here a subscriber which subscribes to the camera image. In Simulink, you can call a ROS2 subscriber, and then if you double click on that, you'll be able to choose the topic that you want. Right here, I can see a bunch of topics that's being published by the VRX simulator that I've run on another PC. So let me expand this a little bit so you can see all the topics. So you can see there's like a bunch of topics being published from the simulator. Right now, we're going to be using the camera sensor, or the left camera image for this example, but you could choose any of the other sensors for any of the other things that you're developing. So you could use GPS and IMU, and then use a sensor fusion toolbox to fuse them to get better orientation and localization. So that's just an example. You could use a laser. You could use the lidar points to create your own SLAM algorithms, or object avoiding algorithm using vector field histogram, for example. These are things that are already present in Simulink, sensor fusion and vector field histogram and SLAM. So it makes it less difficult when you have it already pre-built in Simulink. So in this case, I'm using the camera image, and then I'm gonna click OK. And then there's another block that's called read image. which basically converts the message bus into a image that can be read by MATLAB. So when it comes as a bus, it's going to be a lot of values or topics in that bus. So we're going to change it to a format that can be read by Simulink. And you can actually configure that using the configure using ROS2 button. So you don't have to input any of the values manually. You just click on this, and that should. Oh, hold on. I think there was a disconnect between the simulator and Simulink. Right. Yeah. So as you can see, you can see all the images that are being published on the network. So since we're using the front left camera, we just click on that, and then it automatically reads what the image size is, and it would use that to configure this dialog box. I'm just going to apply, hit OK, and then go back one step, and then let's look at the publisher now. Before we go on to the image processing, I just want to make sure you guys understand the subscriber and the publisher and how it works in Simulink. So let me zoom in a little bit. Yeah. So the publisher is kind of the reverse of the subscriber, as in it first takes the MATLAB image, converts it into a ROS2 message, which using the write image block, and then publishes it using the publisher block. So you just have to send that image to the write image block. The encoding is predetermined, and I think RGB8 is the default for which should be good for ROS. But if you want to send it as a different encoding, there are a bunch of options that you can choose from. Um, so almost any option available in OpenCV is available here. So you should not have any problem sending images in any encoding format that you would like. And then the publish is just a publisher, which will ask for the topic that you want to publish to, and then the type of data that you're publishing, which is pretty standard in ROS. You're gonna choose a image data type, sensor messages slash image, and then for this topic, I gave it the name masked image, but you could specify your own. Right. So now that the image processing, I mean the subscriber and the publisher has been covered, let's talk about what image processing I'm going to be doing today. So this one is a pretty simple processing algorithm, as in it's going to take the RGB image and it's going to create a mask which will identify objects that are colored in red. So we're going to use the color thresholding app in MATLAB to extract certain colors from the image and then use it as a and then use that mask and publish that as a raw stuff. So let me run the simulation first, and then I'll talk to you about the thresholding. Okay. So as you can see, this is the image from the simulator, and then this is your thresholding output, and you can just see all the red objects in the scene. So I'm gonna change to my simulator here, and then move it around, move the board and the simulator around. I can't show it on the screen because it's in a different PC, but trust me, I am changing the simulator location here. All right, so let me stop this for a second. I'm gonna run it again. just with an updated position because I kind of dragged it to a better spot. You could also drive the boat to get to a better spot. So I just moved the boat so you can see all the obstacles in the simulation, and now you can see that it is able to see all the red um, buoys. So in your scene, if it's not too populated with other obstacles, thresholding and proper image processing techniques might be more powerful instead of directly going to deep learning. So you could do the same with deep learning as well. I covered that in the first webinar, which should be there on YouTube. But if you want to use image processing, which is much less computationally intensive, you could do that. And how I did this is using the thresholding app. So I'm going to save this image as a PNG, which you can do it by clicking on Export to Image Viewer. In a second. Right. Now you can then export this as an image. So I'll tell you why we are saving this as an image in just a second. Uh, oops. Let me switch back to MATLAB. Right. So we have the image saved here. What I'm going to do is go to apps and choose color thresholding app. So once the app is open, let me zoom in. I'm going to load the image that we just took. So let me use the image that we just saved. So once you load in the image, it's going to ask you what color space that you want to use. So the default is RGB, but you have other options too, such as HSV, YBR. Um, but it is taking a second because I'm also running the Simulink model. Maybe I should stop that. Maybe I'll show you guys this one first. Yeah. So again, you can choose different color formats that you want. So I'm going to go with RGB here because I'm trying to, what I can do it in the RGB space. But if you want to do something like lane detection, maybe, then HSV might be a good idea. Um, so it really depends on what kind of application that you're looking at. For this, I'm going to use RGB. And once you load it, you're going to have just closing some extra windows. It's confusing when I switch tabs. Right. So here you can see it gives you an option to choose values in the RGB to basically kind of make a mask on what kind of objects that you want to detect. So if I want to detect just red, what I would do is move this. So it's gonna stop seeing all the blue, but I move too far because you can't see the red as well. This looks good because you can see both the red objects. If I move it too much, then it's gonna lose some of the red as well. Then I'm gonna reduce the green. So this took off most of the other objects. Yep. So this gives you a very interactive way of how to uh, threshold your image. So these are values that you can play with. You can switch to different color spaces and play around. And you can also have images with different lighting conditions and kind of try to find which color space would be optimal for all these different conditions that your robot might be under. So for this one, these values seem to work out fine for me. So what I'm going to do is export this as a function. When I export this as a function, MATLAB automatically creates a function that takes in an RGB image and then outputs a masked RGB image and also a black and white image. So it's just going to take all the values that we set in the thresholder app, and then it's going to kind of create a mask based on the values that we set. So let me switch back to Simulink. So in the image processing task, what I'm going to do is take in the RGB image and then this create a MATLAB function. And when I open it, it's just going to be the function that was outputted from the thresholder. So the same function that was output from the thresholder app takes in the RGB image and then outputs a masked image, which is then fed to the publisher to be published into the raster. So this way you're able to subscribe from your simulator or from your robot, do your processing, and then publish it out. And the thresholder app is really helpful when you have to tune images in the competition. So you can just snap a picture from the competition, upload it to MATLAB, use the thresholder app to find whatever object that you are interested in finding, and then put it back into a MATLAB function. And this also gives you another advantage, as in when you have your processor decoupled from your simulator. So right now I have my simulator running in a different PC, and I have my image processing being done in a different PC. So this helps in the sense that you can always just subscribe from the topic from the simulator, and then do some real-time processing here, and then send it back. This way, you don't have to stop the simulation, change your code, and then run both of them again. This makes it easier to develop multiple algorithms at the same time. Yeah, so let me run this again so you can see how the output looks like. So this output is similar to what we saw in the thresholder, and it can be pretty confident that if it works in the thresholder, it's going to work in Simulink as well because it's just a function that's being exported. Let's stop this one. So again, this is just an example of how you can integrate it with your VRX simulator. If you need to develop, say, a control algorithm, you can just replace this and then subscribe to IMU, GPS, and then have an MPC or any controller that you would like, and then publish thrust commands to your robot, and then see how it performs real time. Because before you generate code out of it, which was again mentioned in the previous videos, you can first run the simulation here and then see how your boat performs in the simulator. And if you're happy with the performance, you can then export that as a ROS node and then deploy it to your simulator. Or if you're actually using the simulator just for testing, but you have a real robot or a hardware that you want to deploy it to, you could do that too. We have great support packages for the Jetson. Excuse me. We have great packages for Jetson, Arduino, and Raspberry Pi. So you could use any of those to deploy your code. Excuse me. So I'm not going to go much into code generation today because I think I've covered most of it in the last two videos, and and this one is pretty simple. But I just want to make a note that for code generation, you want to remove the video viewer part here, or uh, configure so that code generation is only for these three blocks, because this is not code gen supported. So you want to have your subscriber, the processing part, and the publisher being configured for code generation. So let me go back to the presentation. So like I said, not every objective requires deep learning. If you can find a way to do it without deep learning, that would save you a lot in compute and also time, because deep learning does take a lot of time to get it working properly. You need to collect a lot of data, make sure it works, make sure the data is clean, and then train a network to give decent performance. But if you're in the competition and at sometimes when you just have to figure out which buoy to go to, it's better if you use some computer vision techniques, because most of the time the background is going to be blue or green, and then the buoy is going to be a different color, and you should be able to figure it out. But then if there's a lot of overlap, that's when deep learning would be useful there. And deep learning and image labeling and all that is being covered in the first video. And like I said, the thresholding app makes it easy to create masks. So as you can see, it took us only maybe 15 minutes to create that thresholding, uh, kind of isolate the red in that image. You could do that. You could do the same with any other color, or you could also, go to different color space and try to find something that you are interested in identifying in the image. All right. So that is done. Are there any questions?
Yes, we have two questions.
Okay.
The first one is, in Simulink, how can you configure a publisher block to effectively communicate large data sets at high frequency over a UDP protocol while ensuring minimal packet loss and optimal synchronization with the model's simulation time?
That's a good
And he
question,
also
but
said it's a big question too, and there's like a video or something that you can point them to that works as well.
yeah. So UDP communication is something that I can't cover in this video, but I will recommend you to go check out our MathWorks documentation. They do have documents on how to publish data. But if it's a high data set, I don't know if publishing over Simulink would be the right answer. So I can get back to you on that one. And I would also encourage you to send an email to roboticsarena@mathworks.com so we can have a look at what particular case you're working on and recommend the best action for that.
And we can go ahead and put that into the chat here on YouTube. The second question, and I can start with this one, Abhishek, and then you can
Mhm.
cut in. is about VRX. So they said, could you talk more about what VRX is? How could I join it? I just joined my school's robo sub team, but we had a catastrophic failure, so we won't be able to go to the competition this summer. So first of all, we're sorry to hear that you had a catastrophic failure. You are always welcome to join us on site at RoboSub and just check out what the other teams are doing and kind of get a feel for the competition. So don't let that be the reason you guys don't attend. But the second question is what VRX is. So the Virtual Robot X Challenge is sort of an off-season virtual version of our Robot X Challenge. So Robot X is a multi-domain robotics program. So our teams essentially outfit a 16-foot long wave-adapted modular vehicle, WAM-V. So the vehicle that you've seen Abhishek working with here looks kind of a pontoon on the VRX side is the simulation-based version of that. So if you're not able to get your team going, thank you so much, get your team going with an actual vehicle and kind of, it's a higher threshold to entry. We really highly encourage your teams to participate in this virtual version of it, the Virtual Robot X Challenge. So this year it's not happening, but next year it will be. But the other amazing thing about this particular simulator, which is available to everybody, it's free right now, is that you can utilize it just to kind of gain some more knowledge and things for other competitions that you're participating in, especially in the maritime side. So it's a fantastic tool to learn about software like MathWorks, Simulink, and MATLAB and everything, and just kind of wet your toes in this particular field. So I'll pass it over to Abhishek, and he can kind of add some additional information on it.
Yeah, I think Alicia covered most of it. I'm just going to add on the first part. I'm sorry to hear that your sub failed, but like Alicia said, you should still try and make it to the RoboSub competition because a lot of teams are super helpful and they would always give you pointers on what to fix on or what to work on. And also just being in the competition would give you an idea of what actually goes on and what kind of strategies other teams use. So it gives you still experience to build on for next year. And for the VRX, like Alicia said, it's a great tool. It's open source. It's free for everyone. You should be able to install it from GitHub. And you could also switch this Wambi style boat for a Robo boat, which is also another competition from RoboNation. So that is something that you could do and then test your algorithms. So it could be anything from image processing, control algorithms, sensor fusion to like doing actual task in the competition and making sure all your um, algorithm works. So it's a great way to learn about robotics at a much lower cost of entry, and you could also play around with different um, boats and algorithms to also learn more about this field and maritime robotics in general. Any other questions?
That is it right now in the chat. Thank you.
Okay. Uh, Speaking about the robotics and the VRX simulator, we do have a MathWorks award being announced for this year. So if you haven't heard of it, make sure that you apply. Make sure that you also apply for the MathWorks award if you're going to be competing in the robotics this November. The award's worth about $2,000, split between the first three people in the competition. And we'll be talking a lot more about it in the next Robotics Team Time, which is scheduled to be on July 10th. Alicia, please correct me if I'm wrong. But it's next month, and we encourage you to join that if you're already participating in robotics, so you can learn more about.
Fantastic. And like Abhishek said, we've got our team time next month on July 10th. In addition to that, we'll get out an email specifically to our Robot X teams, just with a little bit more details about how to apply for this. It will be along with all the other material that you'll be submitting this September. So it's a fantastic opportunity. Not only is there an opportunity for a cash award, but it's a great chance for you guys to learn a little bit more about how to discuss and use those soft skills about what you're building and creating and how you're implementing it with your vehicle. And in addition to that, part of it is that you'll be able to have the chance to do a guest blog on the MathWorks website, which is a super cool opportunity. And we're really excited that they're going to be offering that to you guys. So it's great resume building material. And like I said, it's an awesome chance for you to flex those skills on the communication side.
Yeah, that's right. Because the blog will be featured in the MathWorks website, which not only exposes your work to all the MathWorkers here, but also a lot of people interested, a lot of employers interested in this field. So it's a good way to put yourself out there and then make yourself visible to all these robotics or tech enthusiasts who are looking for people to work in their teams. So it's a great opportunity for you guys. Make sure you look into it and participate in this. But that's all I have for today. If there are any more questions that you have, either for the VRX or the RobotX award, or any of the content that I created or covered in the last 3 videos, feel free to message me or email us at roboticsarena@mathworks.com, and we usually get back within a day or two maximum. And if you're competing in any of the RoboNation competitions, again, you can always email us for any problems that you're facing if you're using our tools to solve a particular challenge in that competition.
Thank you so much, Abhishek. We're very excited again that you were able to join us today. Like you said, if you've got any questions, please don't hesitate to reach out to them at roboticsarena@mathworks.com. We'll make sure that we send that over to you guys in the email. It's also available in the chat here. Like he also mentioned, feel free to reach out to RoboNation directly. So you can reach us at humans@robonation.org. If you have a specific question about one of our autonomous programs, feel free to reach out to autonomy@robonation.org as well. Again, those will be in the chat, and then we're also going to send out an email to our whole community after this. We're really, really thankful that you joined us during these 3 mini-series sessions. If you weren't able to join us live, but joined us after the fact, thank you as well. Feel free to add questions into the comments too. We look forward to seeing you guys at our various competitions this year. And for our RobotX students, we really hope that you apply for this RobotX MathWorks Award. Thank you so much.